Hello and welcome back to another video. So today we're going to be doing last stone weight 1046. You're given an array of integers where stones, the array is stones at a ith index is the weight of the ith stone, and what we want to do is choose the two heaviest stones and smash them together. So if x is equal to y, if one stone is equal to the other, both are destroyed, and if they aren't, then the stone of weight x is destroyed, and the stone of weight y has the new weight y minus x. And at the very end of the game, there is only one stone left. And what we want to do is return the weight of the last remaining stone. If there aren't any stones left, we want to return nothing. Okay, so we have this example over here where you have an array of stones. You combine 7 and 8 to get 1. So this array then converts to 2, 4, 1, 1, 1. Okay, that makes sense. Then you combine 2 and 4 to get 2. So 2 and 4. And then we get 2. So the array converts to 2, 4, 1, 1. And then you keep going until you get 0. So that's going to be the final value of the stone. Okay. So I guess what we have to do is just do as it says. Choose two heaviest stones, smash them together. Now, the best data structure for this to be optimal with is by using a heap. And the reason why is because a heap, if you heapify it, as in you convert an array so it's put inside to a min heap or a max heap, after that operation is done, the act of grabbing a element is log n for grabbing the maximum element from the heap. So what we can do then is first we convert the stones into a max heap, and then what we can do afterward is we can iterate through grab the top element and the second to top element and then compare to see whether or not one is larger than the other. If so, then we basically follow the instructions of the problem over here. So let me begin implementation of this, see how it begins. First thing we want to do is we want to heapify the stones array. So what we can do is we can do heap q, and then I think there's a private method inside the heapify data structure for Python, which you can use to do a max heapify. So do heapify max stones. The next thing that you want to do is you want to iterate through while the length of the stones array is greater than 1. You want to keep smashing it over and over again, right? So while the length of the stones array is greater than 1, what we want to do is we want to smash them together. So the first thing we want to do is figure out grab the maximum. So we want to grab maxi, and then we'll have that equal to the heap q dot heap pop max of the stones array. So now that we have the maximum, we want to determine what the difference is between that. So that and the next largest one. So what we can do is we can figure out what the diff is, and we could do that by subtracting the maxi minus the stones at the 0th element, because that's the element at the top of the heap. So next thing we want to do then is we want to check to see if the diff is positive. Then what we want to do, like the instruction says, is we want to we want the new stone to be equal to the difference between them. So what we can do, we need to pop the last elements, and then you want to add the new element into it. So what we can do is a heap q dot heap replace, and then what we want to do is we want to replace the stones and then the difference. Otherwise, if they're both equal, then you just want to pop it again and remove both the maxi. Well, that's already been removed, and then you want to remove the second one to simulate it being popped out, right? So then we do heap q dot I think this is heap replace max, and then we do heap q dot heap pop max of stones as well. Now at the very end, what we can do is we can append 0 in case there aren't any elements which are left over for I guess like if all of the stones have been smashed together. And then at the very end, we can return the final element in stones, because once it's equal to 1, that should be the remaining stone. So we can do return stones 0. So if you go ahead and run this, okay, we're accepted. Time complexity wise, this should be n log n, because the operation of doing a heapify max should be O of n. And then afterward, when you're grabbing at every single time, like smashing the stones together, the act of grabbing it should be log n. So there should be n log n time complexity, whereas the space complexity should be O of n. Well, yeah, well, the space complexity, you're modifying the stones array in place. So the only memory that's going to be used is the actual stones array itself. So it depends on if you're counting. Well, I guess since you're storing the stones array, like since you're modifying it in place, it could be treated as O of 1 if you don't count the actual stones thing itself. So if we go ahead and okay, never mind, we can't analyze the complexity, but yeah, that's the video. Thank you for watching.